AI explained in 12 minutes.
Chapter 1. The types of AI. Before AI, machines were built to follow our specific instructions. They did things based on conditions we programmed into them. They were rules-based, but AI is different. Instead of giving machines instructions on what to do and how to do it, we train them to think and do things on their own, like raising a child. This is why people call AI a black box. It turns your input into an output based on similar things you've shown it in the past, but you don't know what's happening in the box exactly. AI basically combines your input in the moment with the data it's been trained on to generate an output. And there's 3 types of AI boxes you should know about, and you can differentiate them based on their output. First, we have predictive AI, which labels things based on prior data, like marking an email as spam, identifying someone in a picture, or recommending what you should watch. Generative AI creates new content like text, images, and videos. Agentic AI outputs actions based on a given task. Like self-driving cars, they take a destination as an input, then they plan the trip, drive the car while stopping at traffic lights, following speed limits, and not running over pedestrians. Another example is AI agents like cloud computer use. If you give them a task, they can access your computer, apps, or accounts to execute actions on your behalf. These are the types of AI, but you can also define AI by its level of intelligence. Narrow AI is built for specific tasks, which applies to all AI systems we have today. Artificial General Intelligence, or AGI, is theoretical for now, but would match human intelligence across all tasks and scenarios. But nobody agrees on a formal definition of what AGI actually is. And finally, artificial superintelligence is also theoretical, but would surpass human intelligence by far. Chapter 2. How AI is created. Imagine you adopted a pet robot, and you wanted to teach him how to think and do things on his own. This is called machine learning, and there's 3 ways you can do this. You could take your robot around the world and point at every object to teach him what it is, over and over again. You're spoon-feeding him information until he recognizes what each thing is. This is supervised learning, and you're feeding a machine a sandwich of labeled data like reviews, emails, and even x-rays. You could also take a hands-off approach by letting him learn on his own. Imagine you were leaving the house and you told your robot to sort the dishes. It would start grouping things based on similarities in shape, size, and color. This is unsupervised learning, and it powers systems that group similar items when you're shopping, browsing pictures, or getting song recommendations. The final way you could teach him is with positive and negative reinforcement, like a coach. Imagine you asked your robot to make you a smoothie. It has no idea how to do it at first, so it starts experimenting with random recipes. After you taste each smoothie, you give it a thumbs up or a thumbs down. Over time, the robot learns to make smoothies just the way you like them. This is reinforcement learning, and it's one of the ways ChatGPT was trained to improve its answers, and the reason why your algorithm knows you too well. Creating intelligent machines isn't just about the training method. It's also about the quality of data that you use. If your robot learns from low quality information, he'll only give you low quality results. Garbage in, garbage out. High quality data is more valuable than ever, but we might run out of it soon. One research group predicts that we'll run out of publicly available data between 2026 and 2032 at the current pace of AI development. This is why AI companies are signing expensive licensing deals to find new training data. The other solution being explored is using synthetic data generated by AI to create new training data. Chapter 3. How AI becomes biased. Training an AI system is like raising a child. The parents play a big role in deciding the values they teach them, what they can watch on TV, and where they live. And these factors shape a child's worldview. Imagine a child who grew up in Antarctica and the only animal they ever saw was a penguin. They would think that penguins are the only animals in the world. But they have an incomplete worldview because they haven't seen all the other animals that exist. AI has the same problem, which can limit its abilities, but also create unfavorable outcomes for some people. And this bias can come from different sources. First, the beliefs and values of people can influence how AI systems are designed and trained. If the child's father was an avid penguin enthusiast, he might constantly talk about how penguins are the best animals on Earth. The child would adopt the same belief because it's all they've been exposed to. And this is the same reason why some chatbots will respond differently if you ask them and controversial questions. Bias can also exist within the training data if it has any imbalances that ignore the nuances of the world. If the parents only give their child books about penguins, there is no way for them to learn about new and different species. This is why language models might give you lower quality responses in languages other than English. Bias can also emerge from incorrect and oversimplistic rules that a machine identifies during training. The child who has only seen penguins would think that animals are only creatures that are black, white, and have flippers. And this is why image generators associate certain jobs with specific genders and races. Unfortunately, there's no reliable solution to eliminate bias from AI. After all, bias is part of being human, and if we're trying to replicate the way humans think and act, bias is inevitable. AI is only a mirror image of us after all. Chapter 4. How AI generates text. Imagine you wanted to become a DJ. You would start by listening to as many songs as possible. You would break down each song to analyze the sequence of beats and instruments that were used. And after lots of listening, you become comfortable creating unique beats and mixes that sound good to the ear. Large language models are built in a similar way. They're trained on millions of pages of text. Each piece of text is broken down into tokens, which are numerical representations of words. With billions of examples, machines can remember the sequences of tokens to create language that sounds good to the ear. Asking AI to generate text for you is like requesting a song from a DJ. Based on your request, the songs learned during training, and the mixers, the DJ creates a unique music mix for you. With language models, your text prompt is combined with the training data and parameters to create a new mix of text. Text generation is like a math formula. It takes your inputs, multiplies them by specific parameters to give you a token of text. Except that language models have billions of parameters. AI generates this new mix of text by predicting the sequence of tokens one at a time based on all previous tokens. And each token is the result of hundreds of billions of calculations. Like a DJ anxiously trying to keep the crowd going after every beat switch. But sometimes things go wrong. Since every token is a best guess, these guesses can be wrong when asking for factual information. These are called hallucinations. Remember that language models are text generators, not truth generators. Chapter 5. How AI generates images. Imagine you were a sculptor and someone asks you to make a statue. You would get a stone block and start chiseling away until you get your masterpiece. AI generates images in a similar way. It starts with an image full of random pixels and gradually adjusts them until you get the final result. But how does it do that? The process is called diffusion. These models are trained on billions of images with text descriptions. But machines don't see images like we do. They see them as grids of pixels, and each pixel is represented by 3 numbers for red, green, and blue. When you train an AI model on billions of images, it starts recognizing what words are associated with which pixel patterns and values. This creates a multi-dimensional map called the latent space, and it maps specific features like a shape, artistic style, or color to their pixel values and patterns. To capture all these fine details, these models are trained by taking each image and slowly randomizing all the pixels until it becomes pure noise. Then the model is trained to reverse the process to reconstruct the original image. So when you ask AI to make an image for you, it's replicating that reversal process by taking an image with random pixels, adjusting the pixel values based on the latent space until it constructs the image you want. Chapter 6. The energy cost of AI. Every time you ask AI a question, that request is sent to a data center and processed by thousands of AI chips. Because the hardware in our phones and laptops isn't powerful enough to do it. These data centers need 2 things to operate. First, they need electricity to run. In 2024, data centers use 2% of the world's electricity, but this number is for all data centers that keep the internet running. We don't know what share of that can be attributed to AI alone. It's estimated that a single AI request uses 10 times more energy than a standard search. But this estimate is based on AI models from 2023, which are much smaller than the ones we have today. Second, they need cooling systems to prevent overheating. Most cooling systems use fresh water, and the average data center consumes 300,000 gallons of water every day, which is equivalent to 19,000 showers. And depending on the cooling method used, data centers may lose some or all of this water and need constant replenishment. Unfortunately, we don't have precise or reliable numbers for how much energy or water AI uses alone, because tech companies aren't revealing the size of their newest AI models. What we do know is that AI developments and usage are likely to keep increasing over the next few years, which will require more data centers, aka more electricity and water than before. Thankfully, some solutions are starting to emerge to make AI more energy efficient. And here are 3 you should know about. First, we could run AI on our personal devices instead of data centers because they've been getting more powerful hardware. This is called Edge AI, and we're already seeing signs of it. For example, the new iPhone can run basic AI features on your device directly without sending those requests to a data center. Another solution is called model distillation. The idea is to create smaller models based on large models to make them more energy efficient and cost efficient for specific tasks. Because we don't always need the biggest and most advanced model if a task is simple. The same way we don't need a Formula 1 car to deliver a pizza. Finally, the AI chips and data centers are getting more efficient, which means they need less energy to produce the same output. Over the past 8 years, the energy cost to generate 1 token on an NVIDIA GPU went down from 17,000 joules to 0.4. Chapter 7. A brief history of AI. The story of intelligent machines begins in 1950, when Alan Turing famously asked, "Can machines think?" and proposed the Turing test as a measure of human-like intelligence. But the term artificial intelligence wasn't born until 1956 during a summer research project at Dartmouth College. From the 50s to the 70s, the AI field received generous government funding from DARPA, and the field witnessed its first breakthroughs, like Eliza, a chatbot that could talk to you like a psychotherapist. The hype and expectations around AI at the time were sky high. Some researchers even made bold predictions, like saying that machines would be as smart as we are within 8 years. But the industry faced a massive blow once it couldn't deliver on its promises. 2 government reports from the US and the UK concluded that AI was more expensive, less reliable, slower, and not solving any useful problems yet. This sent the industry into its first winter where funding dried up until the 80s. The field went through a slight resurgence after Japan invested heavily in its computing industry, which pressured the UK and the US to do the same. But they failed to deliver on their promises again and entered a second winter. At this point, 40 years had gone by with no fruitful applications of AI, and the industry was at rock bottom. Some computer scientists were even ashamed to say that they worked on AI and avoided the term completely. But things were about to take a dramatic turn in the late 90s because the perfect storm was brewing. First, computers were becoming way more powerful quickly. Computer chips today are 40 million times more powerful than they were 50 years ago. Second, there was way more digital data available as we moved all of our lives and work online, which could be collected as training data. And both of these things enabled machine learning algorithms that can replicate and simulate intelligence. Since the 2010s, the AI field has slowly recaptured the public's attention and became an overnight sensation with the release of ChatGPT. Big tech companies are racing to the top, everyone has an AI startup, and people are torn between the benefits AI can provide, the harm it creates, and most importantly, the existential question. If AI can do it all, what am I good for? The future is hard to predict, but it feels like the real story is just beginning.
I hope all of this gives you a good understanding of what AI actually is. And thank you for watching my first YouTube video. If you have any questions or feedback, leave them in the comments. I'll take a look at them so I can keep making better videos, and I will see you in the next one.